Why did factoring become important in mathematics history? Imagine trying to solve a puzzle with many pieces scattered around. Without a way to organize those pieces, it would be nearly impossible to see the full picture. That's what factoring did for mathematicians. It helped them break down complicated polynomial expressions into smaller, easier parts. Factoring became important because it made solving equations much faster and simpler. Before calculators and computers, mathematicians relied on these methods to find solutions to polynomial equations, especially quadratic ones. Factoring the greatest common factor is like finding the biggest piece that fits into all parts of the puzzle. It reduces the complexity of the polynomial and sets the stage for further steps. Throughout history, mathematicians needed tools to understand how polynomials behave. Factoring allowed them to see the roots or solutions of equations by setting each factor equal to 0. This was a big step because it turned complex problems into straightforward calculations. For example, if a polynomial can be written as a product of factors, solving the equation becomes just solving each factor separately. The development of factoring techniques helped algebra grow from basic arithmetic to more advanced problem solving. As polynomials of higher degrees appeared, factoring became even more essential. It showed how these expressions could be broken into simpler polynomials, revealing their structure and how they graph. Historically, solving quadratic equations was one of the earliest uses of factoring. Ancient mathematicians like Brahmagupta found ways to solve these types of equations. During the Renaissance, mathematicians such as Scipione del Ferro and Niccolò Tartaglia made breakthroughs by finding methods to factor cubic polynomials. These advances marked major progress in algebra's history. Before the invention of modern tools, factoring was often the quickest way to find solutions. It was more reliable than guesswork or lengthy calculations. Recognizing the greatest common factor is a fundamental step because it simplifies the polynomial and makes further factoring easier. This process helps students understand the structure of polynomials and prepares them to solve more complex equations. Overall, factoring became a key part of mathematics because it simplified complex expressions, helped solve equations efficiently, and pushed the development of algebra forward. It remains a core skill for anyone learning about polynomials and their solutions today.